Hello and welcome to Mr. Clee's video for C5 quantitative analysis. This video is on concentration, dilution and GDA. So the aim of this video is to help you to carry out calculations involving concentration, volume and the number of moles, being careful to watch out for conversions from litres, i.e. dm3, into cubic centimetres. I'm also looking for you to be able to calculate volumes needed in dilutions and also for calculations based on GDA, which is guideline daily amount for sodium. Firstly, the idea of concentration. The idea of concentration is that essentially within a solution you have solvent and solute particles, the solute being the dissolved solid within the solvent, often water. On the left we have a diluted solution that has very few solute particles, and on the right we have a more concentrated solution which is a higher proportion of dissolved solute particles within the solvent. In order to work out concentration, there are two ways that you can do this. You can either do concentration is equal to the mass of the dissolved solute divided by the volume in dm3, or the concentration is equal to the number of moles of dissolved solute divided by the volume in dm3. First thing to be aware of is that you need to make sure that you're using the correct units for volume. You might be asked to do questions in cubic centimetres or in litres given dm3. If you've got to convert from cubic centimetres to dm3, then you need to divide by 1000. So 1000 cubic centimetres is equal to 1 litre. To go the other way, you need to multiply by 1000. Two examples here. Converting from cubic centimetres to dm3, you do 25 divided by 1000, and converting from 0.4 dm3 to cubic centimetres, you multiply by 1000. There's three examples for you to try at the bottom. Might be a good idea to pause now. For all of these you need to convert into dm3, which is litres, so you need to divide by 1000. 2000 divided by 1000 gives you 2 dm3. 500 divided by 1000 is 0.5 dm3, and 120 divided by 1000 is 0.12 dm3. This step is one that people often forget, and is a nice easy mark when you're given any sort of calculations involving concentration or involving moles. This slide's not come across very well, but essentially what we have is concentration is equal to the number of moles divided by the volume. This triangle represents the equations there. Concentration is equal to moles divided by vol, and the number of moles is the concentration times the volume, and the volume is equal to the moles divided by the concentration. It's a good opportunity to have a go at a calculation yourself, seeing if you can work out the concentration of a solution that contains 4.5 grams of sodium chloride in 500 centimetre cubed of a solution. The first thing you need to do is to work out the number of moles of sodium chloride that are present. To do that, you do the mass divided by the molar mass of sodium chloride, which is 4.5 divided by the molar mass of sodium chloride, which is 58.5. The number of moles there is 0.769. The volume of the solution needs to be in dm3. So if you divide 500 by 1000, that gives you the number of the volume in dm3 of 0.5. Using your calculation to work out concentration from the previous slide, which was 0.769, or the number of moles divided by the volume of 0.5, it gives you a concentration of 0.15 mole per dm3. Again, this is a good opportunity to pause and have a go at some questions for yourself. I apologise, the PowerPoint has not worked fantastically well here. Again, what we should have is the number of mole divided by the volume to give you the concentration. So in the first question, calculating the concentration of 250 cubic centimetres of a solution containing 0.1 mole of the solute. First thing to do is divide that by 1000 to get it in dm3, which is 0.25. And if you do 0.1 divided by 0.25, that gives you, I believe, 0.4 mol per dm3. In the second question, we're working out the number of moles, so you need to do the concentration, which is 0.5, multiplied by the volume that you have, which is 2, which gives you 1 mole of solute in 2 litres of a 0.5 mol per dm3 solution. And in the final question, calculating the volume of a 2 mol solution that contains 0.5 moles, you need to do the number of moles, 0.5, divided by the concentration 2, to give you 4 litres or 4 dm3 of solution. Moving on to dilution and how to calculate dilution. Here's a problem for you. If you had 20 cubic centimetres of a 1 molar solution and wanted it to dilute it to a 0.1 mol solution, what would you do? Well, when you're dealing with nice ratios like this and you've got basically a tenfold dilution, most of you should be able to see that you need 200 mil or 200 cubic centimetre of the final solution. So you need to add 180 cubic centimetres of water to dilute the solution. But there are mathematical ways to do this. They all centre about calculating the volume of water to add. The first one is to get the starting concentration, divide it by the target concentration, subtract 1 from that and multiply your answer by the starting volume. So your starting concentration in the example before was 1, divided by 0.1 is 10, minus 1 is 9, times that by the starting volume of 20, and that gives you 180, as we said. The second version pretty much says the same thing in a different way. The starting volume of 20 times by the number of times the solution will be diluted, which in this case is 10, which is so 200, minus the starting volume of 20, again gives you 180. Here's one to try for yourself. You can pause this before you have a go. The way I do this, it's a 5-fold dilution. There's 0.5 divided by 0.1 gives you 5. So your end volume is going to be 5 times that, so it's going to be 50 cubic centimetres, minus your starting volume of 10, so you need to add 40 cubic centimetres of water. And finally, looking at the guideline daily amount of different nutrients you would be getting in your diet. So nutritionists have essentially worked out the amount of different things that you need in your diet to stay healthy. You can see here that there are differences between children, women and men, with men requiring the most of these different nutrients. So if you were asked to work out what percentage of someone's GDA was in a particular meal, what you need to do is you need to know what their GDA was, which in this case is 20 grams, how much is in one portion of that food, which in this case is 5 grams, and just work out a percentage. In this case, 5 divided by 20 times by 100, because it's a percentage, gives you 25%. The problem comes in when you're talking about salt. The issue with salt is that not all of salt is sodium. The percentage by mass of sodium chloride, that is sodium, is 23 divided by 58.5, which gives you about 39%. So 39% of salt is sodium. You need to be careful when looking at these, which one it's asking you to do. You may be asked to calculate the number of grams in a certain meal that was sodium. So the first thing you'd have to do is to calculate the percentage of sodium in sodium chloride, 39%, and multiply that by whatever the amount of salt. If we use this example here with the naan bread, 1.8 grams of that, 1.8 grams of salt in that naan bread. How much of that is sodium? You get your answer, which is 0.39. Multiply it by 1.8, and that would give you an answer of about 0.7 grams of sodium in there. All of these questions are to do with relating the amount of sodium in salt to the GDA. So you need to firstly always remember to calculate the amount of sodium in sodium chloride, about 39%, and multiply that by however many grams you're being asked to use. Incidentally, it's not always accurate using salt content to calculate sodium content, because there might be other compounds within the food that contain sodium but are not necessarily sodium chloride. That concludes this video on calculating concentration, dilution and GDA. If you've got any further questions on this, please see me, I'm Mr. Clee, or any of your science teachers for further help.